The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. All right, so today we're going to start chapter 10. Section 10.1, and the subject is called the square root property. So let's take a look at that. Suppose we had the following equation. Let's try that again. X squared equals 9. Well, wouldn't 3 squared equal 9? So x equals 3 is a solution, but wouldn't -3, the quantity squared, also equal 9? So x equals -3 is also a solution. So this equation, which is a second degree equation because of the exponent of a 2 on the variable, this equation has two solutions. Now, how could we get to that? One of the ways we can do that is to use the square root property. If we have an equation in the form of a perfect square, which contains a variable, in this case, x squared, equals a constant, which in this case is 9, we can take the square root of both sides of the equation. The square root of x squared is x, the square root of 9 is 3. But a minute ago, we looked at the fact that there were two solutions. X could be 3 or -3. So when we take the square root of both sides of the equation, we're going to use this notation, which is plus or minus. So we would say the square root of x squared equals plus or minus the square root of 9, or x equals plus or minus 3. Now, in WebAssign, they don't use this notation. So what you would do is you would say x equals -3, x equals 3. Okay, so we have two solutions. Let's take a look at another example. W squared minus 47 equals 0. So here again, we have a second degree equation, but we want to isolate the square from the constant. So we're going to add 47 to both sides of the equation, and we get w squared equals 47. Then, taking the square root of both sides of the equation, we get w equals plus or minus the square root of 47. Now, the square root of 47 doesn't simplify any further, so w equals negative the square root of 47, comma, the square root of 47. Those two solutions. Let's take a look at another example. Here we have u squared minus 24 equals 0. So to isolate the square containing the variable, we'll add 24 to both sides of the equation. Now we have a perfect square containing a variable equals a constant. Taking the square root of both sides, we get u equals plus or minus the square root of 24. However, the square root of 24 can be simplified further, as we learned in the last chapter. So this would be the square root of 4 times 6, which is 2 square roots of 6. So u equals plus or minus 2 square roots of 6. So we'd say u equals -2 square roots of 6, comma, and then the positive 2 square roots of 6. And we don't have to put the plus sign in front of the positive value. Okay, let's see here. Now we have x minus 1, the quantity squared, equals 4. So again, we have a perfect square containing a variable on one side of the equation and a constant on the other. So it's already good to go. We'll take the square root of both sides of the equation, and we get x minus 1 equals plus or minus 2. 2 being the square root of 4. But we haven't solved for x yet. So we're going to come back and we're going to add 1. So we get x equals 1 plus or minus 2. So splitting those apart, we get x equals 1 plus 2 and x equals 1 minus 2. The 1 plus 2 is 3. The 1 minus 2 is negative 1. So x equals negative 1, comma, and 3. Those two solutions. Here comes another example. We have the quantity s minus 7 squared equals 9. So again, we have a perfect square containing a variable set equal to a constant. So we'll take the square root of both sides of the equation. And again, the plus or minus on the right side. So now we get s minus 7 equals plus or minus 3. We'll add 7 to both sides. So s equals 7 plus or minus 3. Make sure you put the plus 7 in the front instead of after the plus or minus 3, because otherwise you might think that the plus or minus 3, that plus or minus also goes with a 7, and it doesn't. So s equals 7 plus 3, which is 10. S equals 7 minus 3, which is 4. So s equals 4 and 10. Okay, let's see here. Now, this says, let f of x equal x plus 5 squared. For what value or values of, oops, that's a little too close there, of x is f of x equal to 3. So what we're going to do is put 3 in the place of f of x. So we get 3 equals x plus 5 squared. And dealing with it this way is fine, but I always like to have my perfect square on the left. So I'm just going to switch it around, which doesn't change anything. Do it like that. Then we'll take the square root of both sides of the equation. So we get x plus 5 equals plus or minus the square root of 3. Then we'll come back and subtract 5. So we get x equals negative 5 plus or minus the square root of 3. We can't do anything to simplify the square root of 3. So x equals 5 plus the square root of 3, negative 5 plus the square root of 3, and negative 5 minus the square root of 3. So those two solutions, and again, I'm separating them by a comma. WebAssign may ask for two solutions separated by a comma. It may ask you to write them in this form. You'll just have to take a look and see how it expresses it. So depending on how they ask, you would write it one of those two ways. Okay, well, really, that's all we're going to look at today in section 10.1. So this idea, the square root property, where you set it up where you have a perfect square containing a variable on one side of the equation equals a constant on the other side of the equation. Then you take the square root of both sides and continue to simplify. That's all I've got for you today. So I hope you have a great rest of the day. And I'll be back at 1:15 with an office hour. Bye now.